linear and non-linear static analysis in ansys.
In this video, you will learn equation of motion, difference between dynamic and static equation, and when can you use static analysis, linear and non-linear static analysis, step-by-step modeling, preprocessor, solution, and post-processor. Linear and non-linear static analysis of one-by-one story frame modeling, step-by-step, solution setting and post-processing, deformation shape, stress in bone method, and base shear roof displacement curve. Calculated seismic behavior of factor of opacity curve, strength, stiffness, ductility, inertia absorption, and behavior or multiplication factor.
The general equation of motion governing the system is mu double dot plus cu dot plus ku equal by ft, where the external load ft applied to the component gives rise to acceleration, velocity, and displacement. The component of mass multiplied by acceleration is called to the inertial force. The component of damping multiplied by velocity is called the damping force. And the component of stiffness multiplied by displacement is called to the stiffness force. In many civil engineering problems, the inertial and damping forces compared to the stiffness force are negligible. Therefore, by disregarding them, the equation of motion reduced to ku equal by ft, which represented the governing for static problems. Moreover, considering the inherent difference between static and dynamic load, the type of analysis can be easily to determine. In other words, if the loading is constant or does not change significantly over a long period of time, the static analysis is acceptable. Generally, if the excitation frequency of the applied load is less than 33% of the smallest natural frequency of the system, static analysis is acceptable. Generally, static analysis is performed using two approaches, linear and non-linear. In this tutorial video, we will examine both methods through example in ansys. At the first, discuss about static analysis in linear part. For modeling and performing static analysis, I suggested you to see our tutorial video for more information. For example, our tutorial video by title is Start Job with ansys, Define element in ansys, Define material in ansys, Solution in ansys, and Post-processing in ansys. As you can see in this chart, in this tutorial video, our goal is to learn how to perform static analysis. So we will model an analysis and one story and one bay frame as a simple example of structure. As you can see in this chart, generally every modeling in ansys includes this procedure. This chart prepared based on my experience on ansys and ansys algorithm. So we can use this for step-by-step guide. According to this chart, any modeling in ansys have three parts that we show them in green number from 1 to 3. Any part have several steps as you see in this chart. First, we perform preprocessor part. I suggest follow this chart step by step. As you can see in this, the first part we have 5 steps. In second part for processor we have 4 steps. And the last part is post-processor. In this project, we want to modeling a one-story one-bay frame as a simple example of a structure and perform linear and non-linear static analysis. As you can see in this chart, to perform a linear static analysis, we go through 3 stages in ansys, 1 per processor, 2 solution or processor, and 3 post-processor. For modeling frame, in this example using bar element, that according as I said in define element in ansys tutorial video using beam 189 element. Material in this example is 235 steel. Thus, according as I said in material in ansys tutorial video, for define linear part of stress strain curve, supply Young modulus, Poisson ratio, and density. The span length of this frame is 5 meters and height of this is 3 meters. In this example, based on my purpose and for save time in processor, but using same section for a beam and column with box subtype. In this frame, use fixed support in 2 points of column base because the lateral bearing system is moment resistant frame or MRF. For loading, we use 600 kg per square meter for dead load, and for live load is 200 kg per square meters. We considering the frame symmetric because of two-dimensional modeling. We must be zero displacement to apply out of plane of beam. The default analysis type in ansys APDL is static. Thus, in this step for performing linear static analysis, it is enough to just run analysis. After analysis is done, review the results such as deformation shape and reaction force. We have separate comprehensive tutorial video about result in ansys. I recommend you to watch it. At the end, this part reviewing ansys command by using exclamation point specify each step of modeling in ansys command for easy using in the future.
Run ansys APDL. As I said before, in this step of education, we want to modeling one story, one wave frame and performing static analysis. Thus, in ansys main menu, click on Preferences. In Preferences dialog box, we choose structural. That means our purpose of modeling is structural. Click on OK. At the first, we want to define element type. We have a separate comprehensive tutorial video about element in ansys. Click on per processor, element type, add, edit, delete. In element type window, click on add. In this element family selection, beam and 3 node 189. Click on OK and close this window. For second step, we must define material property. In this example, we want to use 235 steel material. Thus, in preprocessor, click on material props, material model, and in define material model behavior dialog box. In left column, click on material model number 1 to choose it, and in the right column, click on structural, linear, elastic, isotropic. In this step of education, we want to modeling static analysis in linear form. Thus, after I said in define material property, for linear part, we must define Young modulus and proxy and density. We must enter 2E11, and for proxy or Poisson ratio enter 0.3. Click on OK and click on density for define density for this material 7850. Click on OK. Okay. Close this define material model behavior dialog box. Because of we have a beam element, we must be define section for beam. Click on in preprocessor, click on section and beam and comment section. In beam tools dialog box, we want to define section for beam and column. For save time, in tutorial video use the same section for beam and column. For more information, you can see define beam element in ansys tutorial video. Enter ID 1, name box 20p or thickness 1. In subtype selection in drop down menu selection box and enter W1 or with our section, W2 or half section, and T1 to T4. For W1 enter 0.2, for W2 enter 0.2, for T1 enter 0.01 T40.01 and click on preview to seeing the section. In this part of Vim Tools window, you can change the mesh. Just click on this scroll, enter, and click on mesh view. You can change it by click on file, mesh view. I choose click on it. As I said in modeling chart, in next step we must to draw geometry